In affluent environments characterized by low levels of combustible materials and ignition sources, splicing typically involves residential, commercial buildings, offices, and retail spaces. Explosion-proof standards are designed to prevent the ignition of explosive atmospheres and are compliant with specific codes and regulations such as the National Electrical Code (NEC) and the International Electrotechnical Commission (IEC). Examples include explosion-proof enclosures and intrinsically safe devices. When splicing in affluent environments, using standard electrical tape or splice connectors is generally acceptable. Ensure that the splice is protected from moisture and environmental contaminants and follow all NEC and manufacturer's guidelines for splicing. Splicing in explosion-proof environments requires specific methods and materials. Explosion-proof splice enclosures are enclosures certified as explosion-proof and designed to contain any potential explosions. Intrinsically safe splicing involves devices designed to operate safely in explosive atmospheres without creating ignition sources. Use only suitable splice materials specifically approved for use in explosion-proof environments, such as crimp connectors or solderless terminals. Proper installation involves following the manufacturer's instructions and relevant codes for proper installation of explosion-proof splices. Additional considerations include firstly, identifying the specific explosion-proof requirements for the area where the splicing will take place. Secondly, consulting with a qualified electrician or engineer to ensure compliance. Thirdly, using only certified materials and equipment that meet the required standards. Fourthly, maintaining proper documentation and records of the splicing process. And fifthly, regularly inspecting and maintaining splices to ensure they remain explosion-proof. The National Electrical Code (NEC) provides detailed guidelines for electrical installations, including splicing, to ensure safety and compliance. For affluent environments, standard splicing practices such as using approved connectors and ensuring proper insulation are generally sufficient. However, in explosion-proof environments, the NEC mandates the use of specialized equipment and techniques to prevent ignition of flammable substances. Explosion-proof enclosures are designed to contain any potential explosions within the enclosure, preventing them from spreading to the surrounding environment. Intrinsically safe circuits limit the energy available to a level that is too low to cause ignition. Proper grounding and bonding are also critical to minimize the risk of static discharge, which can be an ignition source. The NEC Articles 500 through 516 provide specific requirements for hazardous locations, classified based on the type and concentration of flammable materials present. It is essential to consult these articles and follow the manufacturer's instructions for all equipment used in explosion-proof environments. Regular inspections and maintenance are also necessary to ensure that the equipment continues to function as intended and that any potential issues are identified and addressed promptly. When selecting materials for splicing in explosion-proof environments, it is crucial to choose products that are specifically certified for use in those locations. These materials are typically made of robust materials and are designed to withstand the harsh conditions often found in industrial settings. Additionally, they must be installed correctly to maintain their explosion-proof rating. Training and certification are also essential for electricians and technicians working in explosion-proof environments. They must be knowledgeable about the relevant codes and standards, as well as the proper installation and maintenance procedures for explosion-proof equipment. This ensures that the work is performed safely and that the installation meets the required standards. In summary, splicing in affluent environments is generally straightforward, while splicing in explosion-proof environments requires strict adherence to specific codes and standards. Proper selection of materials, installation techniques, and ongoing maintenance are essential to ensure safety and compliance. Consulting with qualified professionals is always recommended to ensure that the work is performed correctly and that the installation meets all applicable requirements. Remember that the NEC and other relevant standards are updated regularly, so it is important to stay current with the latest requirements. This will help ensure that your electrical installations are safe and compliant. When dealing with electrical systems, safety should always be the top priority. Following the appropriate codes and standards, using qualified professionals, and performing regular maintenance are all essential steps in ensuring a safe and reliable electrical system. Always verify that any equipment used in hazardous locations is properly certified and installed according to the manufacturer's instructions. This will help prevent accidents and ensure the safety of personnel and property. It is also important to remember that explosion-proof equipment is not necessarily waterproof or corrosion-proof, so additional protection may be required in certain environments. This could include using special coatings or enclosures to protect the equipment from moisture or corrosive substances. Finally, always maintain proper documentation of all electrical work performed, including splicing. This documentation should include the date of the work, the materials used, and the qualifications of the person performing the work. This will help ensure that the installation can be inspected and maintained properly in the future. Consider a scenario where you are splicing wires in a chemical plant. This environment is classified as a hazardous location due to the presence of flammable gases. To perform the splicing safely, you must use explosion-proof enclosures and intrinsically safe wiring methods. The enclosures are designed to contain any potential explosions, while the intrinsically safe wiring limits the energy available to prevent ignition. You would also need to follow specific procedures for grounding and bonding to minimize the risk of static discharge. In contrast, if you are splicing wires in an office building, the requirements are much less stringent. Standard electrical connectors and insulation are typically sufficient as long as they are installed correctly and protected from moisture. However, it is still important to follow the NEC guidelines for general wiring practices to ensure safety and reliability. When working in any electrical environment, always de-energize the circuit before starting any work. This will help prevent electric shock and other hazards. Use appropriate personal protective equipment, such as gloves and eye protection, to further minimize the risk of injury. If you are not comfortable performing the work yourself, it is always best to hire a qualified electrician. They have the training and experience necessary to perform the work safely and correctly. Remember that electrical work can be dangerous, so it is important to take all necessary precautions to protect yourself and others. By following the guidelines and recommendations outlined in this discussion, you can help ensure that your electrical installations are safe, compliant, and reliable. Proper planning and preparation are key to success in any electrical project. Take the time to assess the environment, select the appropriate materials, and follow the correct procedures. This will help prevent problems down the road and ensure that the installation meets your needs. In addition to the NEC, other relevant standards may apply to your electrical installations. These could include standards from organizations such as the Institute of Electrical and Electronics Engineers, IEE, and the National Fire Protection Association, NFPA. It is important to be aware of these standards and to follow them as applicable. Also be aware that local building codes may have additional requirements for electrical installations. Check with your local authorities to ensure that you are in compliance with all applicable regulations. Compliance with these codes and standards is not only important for safety, but also for legal and insurance purposes. Failure to comply with applicable regulations can result in fines, penalties, and even legal action. It is also important to note that the requirements for electrical installations can vary depending on the type of occupancy. For example, hospitals and other healthcare facilities have specific requirements for electrical systems to ensure patient safety. Similarly, data centers and other critical facilities have specific requirements for power reliability and backup systems. Be sure to understand the specific requirements for your type of occupancy before starting any electrical work. Ongoing maintenance and testing are essential to ensure the continued safety and reliability of electrical systems. Regular inspections can help identify potential problems before they become serious. Testing can verify that the system is functioning properly and that all components are within acceptable limits. Maintenance tasks such as tightening connections, cleaning equipment, and replacing worn parts can help extend the life of the system and prevent failures. A well-maintained electrical system is not only safer, but also more efficient and reliable. This can save you money on energy costs and reduce the risk of downtime. In conclusion, Splicing in affluent and explosion-proof environments requires careful consideration of the specific requirements for each location. By following the appropriate codes and standards, using qualified professionals, and performing regular maintenance, you can help ensure that your electrical installations are safe, compliant, and reliable. Remember that safety should always be the top priority when working with electrical systems.